Good morning, guys. I rather good afternoon. Good afternoon, Copper. Today we will be discussing lesson 1 and lesson 2 of our module 1 for TVL2 robotics class. So we will just be coursing through most of the lessons for today. We will be focusing uh, on the more important terms of our lesson. Also, we will be addressing some concerns by the end of our lesson today. So, for lesson 1, it would be the introduction. So, embedded systems. So, what is an embedded system? Embedded system are used in a vast number of electronic devices. Their design involves both hardware and software techniques. So, embedded systems are usually uh, hindi lang natin siya na-notice, but they are usually just around us, usually in our homes. For example, uh, in our washing machines, our microwave ovens, or air conditioning units. All of those usually have what we call embedded systems. So embedded systems are used in a vast number of electronic devices. Their design involves both hardware and software techniques. So what is hardware and what is software? Hardware and software. So when we say hardware is usually the tangible parts of an embedded system. Usually uh, the electronic components of our system, um, the diodes, transistors, capacitors, so on and so forth. We can consider them so hardware. Meanwhile, the software is the parts that hardware use in order to make them function. This is non-tangible, but we know it exists because it makes our hardware function. So it includes program. So we have, let me just, okay. So it includes the program. Sometimes it includes the operating system. Uh, it includes operating system and other parts of our um, the non-tangible parts includes also the firmware. So as computer technology advances, so its technology becomes more embedded in more electronic products. So the number of electronic devices in our homes with embedded systems gets plentier each year that passes. For example, um, TVs nowadays usually have embedded systems, but in the days of the past, it usually just involves knobs to change the frequency. But nowadays, you can even watch stream Netflix directly via your television. So, embedded system characteristics. Embedded systems are designed for a specific task. For example, for the washing machines, usually embedded systems in washing machines are used for uh, the timer control. For the microwave ovens, embedded systems are there for the thermostat, as well as the moisture and heat content inside the microwave. So, embedded systems are designed for a specific task. The software for embedded system is normally referred to as firmware. So, moving on, um, we have discussed hardware and software earlier. Again, hardware includes the hardware platform in which the program runs on, and the software is usually the program in which makes the hardware function. So, embedded systems can be classified into two, which is the microcontroller and the microprocessor-based systems. Microcontroller-based systems are usually those embedded systems that usually have a specialization in their function. For example, um, the ones employed uh, in the microwave ovens, the air conditioners, and the washing machines. We can consider those microcontroller-based systems because they are very specific in their type of task that they can accomplish with. Meanwhile, microprocessor-based systems are those with um, contain uh, more than just processing unit, but it also includes memory and other peripheral devices. Common example would be your mobile phone. It also includes uh, it also includes your smart TV. Everything that we consider smart now is usually microprocessor based systems. Another example or is your computer. It is a microprocessor based system. So you can easily differentiate microcontroller based systems to microprocessor based systems. Microcontroller based systems usually focus on a particular task. Meanwhile, microprocessor based systems usually can multitask a couple of subroutines or tasks. So, embedded system software include machine code and programming language. So, usually, let's go with this. Let's go back. So, usually, um, let's say this is your machine. Let's say, let me zoom this in. Let's say this is your the internals of your computer, or rather your embedded systems. Then this is your desired outcome. Say this is your television, and this is the plug. So elec how is it that electricity is being converted to a display that we can actually utilize? So let's start with the most basic one. First, it starts as an electricity in our wall sockets. Then, electricity is being converted into uh, a more stable current in which signals are being converted into a digital format. So this is a digital format. Then, from a digital format, it is being converted further into what we call the binary code. And from binary code, It is slowly being transferred into what we call as the programming language. So it goes through a lot of process before it is able to display to you what its intended function is. But basically, it starts as a raw electricity, which is an AC, then tamed into DC, then into binary, then eventually into a programming language. If you have any questions, type so in our ICT2 chat just above this channel. Now, moving on. So there are several electronic concepts that we are using. So the electric current. Electric current is the flow of electrical charge in a circuit. I will just show you later on the visualization of how this relates to your robotic subject. So more specifically, the electric current is the rate of charge flow past a given point in an electric circuit. Charge can be negatively charged or positively charged. But mostly, when we refer to as electricity or electricity, is usually negative. After all, the name electricity or electronics comes from the word electron. Electron is a negatively charged particle in an atom. So this negatively charged particle in an atom is uh, what causes the phenomenon we call electricity. So going back, now we have resistance. Resistance is the hindrance of the flow of electrons in the material. So with a potential difference across conductor encourages the flow of electrons, resistance discourages it. So Ohm's law, I think this will be discussed in detail by your what do you call this, your physics teacher. So eventually we'll get there. So, but the Ohm's law triangle here, as it is being shown, is basically the formula is very simple. So inductance or the current is equals to the voltage over resistance. So it could be interpreted as voltage is equals to inductance multiplied by resistance, or resistance is equals to voltage over inductance. So going discussing this topic, ito para medyo klaro. I want you to visualize electricity as a flow of water. In this analogy, we can consider that electricity is a flow of electron. So let's say we have a tank here. After all, electricity is not infinite. It is a finite resource. So let's see here. This is a tube. This here we have about let's say there is a water there. Consider water as electricity or electrons. Electricity is basically just a flow of electrons. So we can consider this one as resistance. We can consider the valve as the resistance. Or even the roughness of the tube. We can consider this resistance. Everything here is a resistance. Now, if you notice, the tube has an uneven shape. You notice the tube has an uneven shape. So the flow is what we consider as current or electric current. So it is the electric current. It is the flow from one place to another. Now, um, again, this is the resistance. Also, if you notice, there is uh, a change in the size of the nozzle here. We consider this one voltage. Voltage, it can be considered as the water pressure, or in this case, it is the electrical pressure. It is the electrical pressure that one can apply to electricity. For example, you can have a very big valve, or rather a very big faucet in which very strong current passes through. So it means it has a high voltage, right? You can easily interpret it as it has a high voltage. But if the water easily drips into it, it just drips, it means it has a low pressure or a low voltage. Do you do you understand?
Yes, I
Current is
understand
usually
now.
current is usually interpreted in the value of amps or amperes. For example, um, for example, the CPUs in your computer only use 1.5 volts, but they use as much as current. They use as much as uh 65 amps. Compare that to your Arduino. Let's say this is the Arduino. Arduino uses usually 5 volts. It can function at 5 volts, but you should let's just say an average 15 volts. But it only uses 500 milliamps or zero point 0.5. So you can compare, you can easily compare which of the two actually consumes more uh, electronic current, right? 65 amps. So you can easily imagine that um, though CPU only uses 1.5 volts of electricity, it consumes as much as 65 amps compared to the Arduino, which is 15 volts, but it consumes only 500 milliamps of electricity. You now get the point, right? So resistance. So for those who were here last week, we have an analogy regarding the LEDs or light emitting diodes, right? Light emitting diodes or LED. Diodes, for instance, is a one-way electronic device, meaning it can only pass through in one way. So it allows this way, but it cannot allow the opposite. So if we push a lot of electricity to it, for example, if we use 5 volts raw in a LED lamp, because most of the Arduino pins usually output as much as 5 volts, the LED will automatically pop, meaning you destroyed your light emitting diode immediately, which is the case during our lessons last year. Gasto kaayo. Um, Lots of students actually broke the LEDs that the school provided because didn't add what we call as resistors. Resistors restrict the flow of electricity to a manageable level. So we use a little bit of resistance to actually get the desired electricity that we want. Now that we have discussed this, let's move on to inductance. Or rather, let's go to capacitance first. So capacitance is effectively the ability to store charge. Take note of the terminology, ability to store charge. In its simplest form, a capacitor consists of two parallel plates. It is found that when a battery or other voltage source is connected to two plates shown, a current flows for a short time, and one plate receives an excess of electrons while the other has too few. So let's go back to our analogy regarding the water. So we can imagine battery as the water tank. Can imagine the battery as the water tank. And we uh can imagine what do you call this? Capacitor as a reservoir. So let's uh draw a reservoir here. So if this is a capacitor, this is a battery. What do you think is the differences in function with regards to battery and a capacitor uh, based on the illustration shown? What do you think is the differences between a battery and a capacitor in our water tank analogy? Any answers from the students? Daryl?
Iba yung ano sir, yung mag-change, different yung maglabas na electricity current or something.
Mm-hmm. Okay. Any other answers? None? So sige, ito na lang. A battery stores its energy as a chemical in a chemical uh, stores energy chemically. Meanwhile, capacitors store energy electromagnetic. So um, hindi to kasali sa analogy, no, na pinakita ko. Pero a battery only drains. Um, because battery is a chemically induced storage, no? It means that it will eventually run out of energy. Hindi mo siya effectually ma-charge forever. It is literally impossible because as we all know, meron tayong chemical decay. Meron tayong pagbabago sa ating chemical. For example, the battery that we use in our phones it is usually nickel cadmium. It will not be like that forever. The battery will eventually die. The battery dies because of the electronic or electrical processes, the chemical ones. Meanwhile, capacitor stores its energy via electromagnetic energy. So, let's draw battery here. They actually look alike. So, this is a capacitor. So, capacitor, ganito yan sa battery. Battery is just ganyan. So, this one is charged with what do you call this? Electrons. Electron charge yan siya. It usually goes back here because of the imbalance. Mura siya og kanang uh, mura siya ingon ani. Let's say this is full of water. If there's a hole in there, it will create a balance, right? It will try to fill up all the other spaces. That's what happens in the battery. The electron will travel back here because of the imbalance to balance out the electricity, the chemical changes inside it. So will eventually even out and produce no more energy. But elec for the capacitor, what happens is that you will flow energy in one side, then there are two plates in the middle. This will become electrically charged because we are pumping energy in it. There is parang tinatawag nating plastic film dyan. It acts like a barrier. So, they do not interact. Pero dahil sa electromagnetism, may mga electrons, excuse me, due to electromagnetism, there the electrons will be able to travel to the other side via electromagnetism. So, how does a capacitor act like a reservoir? So, let's say this is the reservoir. Once the electricity flows here, it tries to fill this up first. It will fill this up. Mali gani dapat ni. Let me just. It is better to state it like this. So before mag-send og kanang kuryente si capacitor, it fills up this uh it fills this up first before releasing energy. One benefit that capacitor can give is that it gives stable electricity or current. So, a capacitor cannot store its energy forever. Excuse me. A capacitor cannot store its energy forever. The maximum a capacitor can store energy to is just minutes to an hour. Nawawala kasi yung magnetism niya pag nawawalan siya ng kuryente. If you notice, pag may AVR kayo sa computer nyo, hindi kagad namamatay yung computer. The computer doesn't automatically turn off it if there is a power outage. It usually takes a split second before the computer turns off. What happens is that the computer consumes the electricity that is stored in those capacitors before it turns off. So that's what happens inside the computer. So if a battery um, is used like a real storage, then a capacitor is a reservoir. Inductance. Inductance is a key parameter in electrical and electronic circuits. Like resistance and capacitance, it is a basic electrical measurement that affects all circuits to some degree. I will be explaining what inductance is in our future lessons, but we will ignore this for now. Decibel. Decibel is a unit that is utilized in logarithmic scale based to compare two quantities. It is a convenient way of comparing two physical quantities like electrical power, intensity, or even current or voltage. So transformers. Transformers are widely used in all branches of electronics. They can exist both big and small. So one of their most well-known applications is that power or it can transform the operating voltage from one value to another. So pakita ko lang sa inyo ano yung transformer ha. Let's say 120 volt transformer. So this is a transformer. We can usually find this in our old machines. Ito, usually find this in old refrigerators. There's even one inside a microwave oven. So how does a transformer work? So a transformer usually is like this. Simple lang masyado ang mechanism ng transformer. There are usually two sets of coils. So these coils, each wind of the coil increases the power output. So let's say it increases or decreases depende sa clockwise or counterclockwise na turn ng ating transformer. So let's say we get 240 volts of electricity from our outlet, di ba? We are using 240 volts from our Philippines are usually using 240 volts of electricity. So inside the transformer, if this is a wind down transformer, you can end up with either a 12 volt, meaning it is a step down transformer. So it is stepping down to 212 volts. So if you notice here, the thick wires are what we are using para isaksak siya sa outlet, those thick wires. So dyan papasok yung 240 volts and one ground. So transformers can usually step up or step down uh, electricity. So transformers is explicitly an AC electronic component, meaning it will not work with a DC or direct current electricity. This is an AC component. I will be explaining what AC and DC is later, but let's move on. So electrical power, okay. Voltage is one of the most fundamental parameters. Voltage is seen widely in specifications of host of electrical items. So I've already explained what voltage is earlier. Semiconductors. Semiconductors um, forms the most electronics in the basis of most electronic industry these days. So I'm sorry to admit this, no, but this is not made by me. The materials is not made by me, but as you can see, it lacks critical information. So I will explain what semiconductor is, but we will be learning what semiconductor is in a bit. So semiconductor acts like it can act both as a conductor and an insulator at the same time. So yan yung basic na explanation ng semiconductor. So one common uh, thing that is being used as a semiconductor is Si or silicon. Silicon is very common. You just go to a beach, dig up some sand, then you end up with silicon. Silicon is usually the most abundant thing that is being used as a semiconductor in our semiconductor systems. So, what is a semiconductor? Semiconductor can function both, again, can both function as uh, it can both function with conductivity or it can even function as a resistor. Meaning you can use it to uh, avoid electronics from passing through from one place to another. So let's teka lang ha. I need pakita ko lang yung visualization. Let me find the visualization of silicon. So silicon, as you might know, silicon is element 14 ba yan? Let me look for ano ha. Uh, Aware pa ba kayo sa valences ng ano ng table nyo? Have you already learned about this?
Somewhat.
Somewhat lang. So,
Opo.
going back here, tignan natin si silicon. Saan si silicon dyan? Nasa number 14 si silicon, right?
Yes, sir. Yes, sir.
So, how many free electrons do you think silicon can offer? Let's say, itong nasa noble gas, for that fact na, ito si nasa noble gases, usually, puno na siya. Kaya siya tinawag na noble gas kasi it cannot interact with other elements, right? But silicon is in a position in which it can either give or take electrons depending on the situation. So, it could be, itong block na to, usually, kagrupo ni silicon, germanium, arsenic, antimony, usually, yan yung mga ginagamit sa tinatawag nating, what do you call this? Yun yung ginagamit as semiconductors. Anong tawag sa group na to? Itong nasa grid na to. Usually nasa line na to. Kasi ito metals na to eh. And this is usually non-metals.
Semi-metal.
Semi-metals, we usually call that metalloids. or nonmetals acting as metals. Ayan o, nakasulat na metalloids. So, usually kasi, sa valence shell nila, sana yung ano nito? Di ba 8 ang required para maging ano siya, stable ang isang ano? But, ilan yung sa ano? Ilan yung sa silicon? It has 4. 4 vacant slots. So, usually kasi ito, pakita ko na lang, mas mahirap i-visualize sa inyo eh. So, this is what happens with silicon, no? Silicon can freely accept a free electron from other element. So, what happens is that meron tayong high purity silicon na chip, or usually uh, high purity silicon. Then, there is a process we call in paggawa ng chip, we call that doping. Doping. When we say doping, halimbawa high purity silicon yan, dadagdagan yan siya ng impurities. Dadagdagan siya ng impurities. Depende sa desired na effect natin ng semiconductor. For example, N-type meaning negative type na semiconductor, dadagdagan siya ng phosphorus. So, it becomes what we call as a hole. So, medyo mahirap siya i-explain. Mas maganda siya i-explain pag ano, nasa electronics na tayo na topic. Pero, sige, yun lang muna. Silicon is being used as a semiconductor. It acts like both a conductor and a resistor at the same time, depending on how we flow the electricity to it. So, ganun lang yung basic na ano niya, semiconductor. So, this is unnecessary information, unnecessary logic and digital. So, dito tayo sa logic and digital. Medyo important to na part. So, ito when we sing, usually, ganito yung maririnig natin. Ganyan. Ganyan yung boses natin pag nagre-record tayo. Pakita ko na lang yung visualization. Usually, Audacity.
Sound wave, sir.
Y-
Sine wave.
Yes, sine wave. So, ito magre-record tayo. Hello, mic test. Hello, hello. Ayan, nakita nyo, di ba may wave?
Yes,
This
sir.
is a digital signal. So how do we differentiate digital from analog? So digital or analog. So usually kasi electronics tayo, digital yung signal natin. So if we zoom into this, you can see that this is digital. It is because tignan yung maigi yung linya. Hindi siya perfect curve. Hindi siya perfect curve. It is just a multiple that it ends up looking like a curve. Analog, meanwhile, is creates a perfect curve. So let's say, example lang to ng analog signal. Meanwhile, a digital signal is a recreation of that signal in digital format. So ganyan ang analog. So, or digital. Recreation lang siya ng signal in we call this recreation of analog to digital as PWM. Makikita nyo yan later sa Arduino nyo, but we call this PWM as pulse width modulation. Teka lang, tignan natin kung may ano ba dito, may example ba sila ng Analog sound to digital. Para lang makita nyo yung visualization ko. So, ito. Ayan ha. Pangit kasi drawing ko. So, ganyan yung nangyayari sa... So, ito yung original sound wave. Analog yan siya. But, if we record something using our computer devices, wala nang analog dyan. It is totally digital. So, this is what happens when we deal with digital things. So, we call this recreation of the analog to digital as pulse width modulation or PWM. So, going back, um, hindi kasi siya na-mention dito. So, decoupling, a major point in any set of logic design guidelines. Okay, unimportant. Okay. So, in many gates, in many circuits, there will be some logic gates that remain unused and important. Okay, it's up to you to read this. So, kasi madaming unnecessary information yung ano. So, I would like us to go through lang sa important na information. So, ito. Regarding sa ano yung gusto kong i-discuss sana. Kalimutan ko tuloy. So, again, there is a difference between analog and digital. So, now let's go on with AC and DC. Alternating current. For this is the brainchild of uh two magnificent inventors of their time, no? One being Nikola Tesla and the other one, sino yung isa? Sige daw.
Column. Ay, dili. Edison.
Okay. Thomas Edison and uh what do you call this? Thomas Edison and Nikola Tesla. So, we are both using this side by side, but uh we have different ways in using this. So, for alternating current, we are using this as a way to transmit electricity. One major advantage of alternating current is that you can transmit it over long distances. For example, ang main source of energy natin dito sa Davao, wala dito sa ating region. Uh, for example, Maria Cristina Falls. Di ba ang layo nun? So, usually it travels very long distances and alternating current is very appropriate when sending electricity to vast distances. But, well, let's go to direct current. Electronic devices hate AC. For one, AC is very untamed. Meaning, hindi siya directly natatap ng ating mga electronic devices. AC is usually can be visualized as a sine wave. For example, this is 0, this is positive, and this is negative. And this is the grid line. Alternating current alternates like this. Ganyan ang alternating current. Meanwhile, direct current is just this. Yan, direct current yan. So, you can clearly see the difference, right? So, for the Philippines, it are sa electrical situation natin sa Philippines, it alternates its electricity 60 times a second, or we refer to this as 60 hertz. Now, it goes up and down from negative 240 to positive 240 every 60 times. Meaning, dyan sa socket ng ano nyo, saksakan nyo ng ano dyan sa wall nyo, it changes from positive to negative 60 times. Meaning, hindi mo talaga masasabi kung negative or positive yung saksakan nyo. Kaya pwede nyong balik-balik ta rin yung saksakan. Ito lang. So, with this, it needs to convert alternating current to direct current first. So usually we use several types of tools to that, in which we will be discussing in our next meeting. So our next meeting will be January 9, ha? We will be meeting January 9. So any questions before we conclude our class for today?
January 9 po, sir.
Yes. Ay, February 9.
Same
Ah,
same time
sige
po.
po.